In this video, we're going to go over the check your understanding from 3.2. Some data were collected on the weight of a male white laboratory rat for the first 25 weeks after its birth. A scatter plot of y equals weight in grams and x equals time since birth in weeks shows a fairly strong positive linear relationship. The regression equation of y hat, so estimated y is equal to 100 plus 40x, models the data fairly well. Interpret the slope of the regression line. So the slope is always that number in front of x. So we have 40. So you want to think as x increases by 1, that y is going to increase by 40. So here's it written out with each additional week, because x is time in weeks. With each one additional week, the predicted weight. Now that's really important that you have predicted there. Predicted weight for a male white lab rat increases by 40 grams, that slope. So make sure you're putting units, make sure you're writing predicted. Does the value of the y-intercept have any meaning in this context? If so, interpret it. If not, explain why. So sure, when a rat is just born at 0 weeks old, when x is 0, the predicted weight, again, make sure you have predicted there. It's not deterministic. We don't know for sure. This is just a model estimating it. Predicted weight is 100 grams. Predict the rat's weight at 16 weeks old. So they're giving us an input and we're finding the output. Now, when you're making this prediction, just make sure you put the hats on the y's because you are predicting it. Don't just write y equals. Your predicted y, your estimated y. Y hat is 100 plus 40 times 16. So your predicted weight, or you could write weight with a hat over it, is 740 grams. Make sure you put units. Calculate and interpret the residual if the rat actually weighed 700 grams. So this would be the true y value. And this was our estimated y. So this is our actual, and this is our predicted, actual and predicted. So when we find the residual, you're going to do actual, 700, minus predicted, and we get negative 40 grams. So your residual has the same units as the y value. Our interpretation, the actual weight is 40 grams lower than our predicted weight when x is 16 weeks. So specify at which x value this residual is occurring. Should you use this line to predict the rat's weight at 2 years old? So that's a different unit, 2 years, right? X is in weeks. Use this equation to make the prediction and discuss your confidence. There are 454 grams in a pound, just for reference. So if you make this calculation, if you substitute 104 for x, that's at 2 years old. The equation is going to predict a male white lab rat to weigh, where is this? There we go. 4,260 grams. So you input 104 to get your estimated weight after 104 weeks, which is 9.4 pounds. I do not want to come across that rat. Right? We do not expect to see a 9.4 pound lab rat, and we do not have confidence in that result. 104 weeks is way too far from the 25 weeks. This is extrapolation, or probably when the rat reaches adulthood, its growth stops being linear with this slope and this y-intercept. It probably levels off in growth. So extrapolation, beware. Do not do it. Okay, so that was the check your understanding. See you later.